Okay, we're going to be talking about the rock cycle today, which is in your book on page 130 and 131. So we have a really nice diagram, and then we have our examples here sitting around the book. Okay, so we know that way deep underneath of the surface of the earth there is magma, and it is all melted. So that's not a rock, that's liquid, and rocks are solid. So the magma is not a rock, but when it cools down, so we've got the melting and cooling, when it cools down, it turns into igneous rock, and that's what we have here. If it cooled down underneath the surface, we have these nice big crystals. If it cooled down at the surface, we have the ones with all the little air bubbles and the sharp little edges on them that are very light and even float in water. So if your igneous rock got weathered, weathering, erosion, and deposition. Weathering means broken up into little tiny pieces. Erosion means carried away. Deposition means it got dumped somewhere else. Then you end up with sedimentary rock that comes in layers. If we were in class, we would take this piece of sandstone right here and we would rub another rock on it until you would see all those little grains start to fall apart. This one has been broken and you can see all the layers there. So when rocks get broken up into little pieces, that's sediment. When it sticks together, that's sedimentation. Sedimentary rock. So the igneous rock doesn't have to get broken up into little pieces. Maybe that igneous rock got squished. Maybe a lot of temperature, they say temperature, I say heat, a lot of heat and pressure might have squeezed it. So here, like we're talking about when plates come together, if you think about the tectonic plates, we're talking about some serious squishing that makes all these little wiggling things happen, and that's how we end up with all these crystals that have been forced into lines or into flat layers like that shale. These metamorphic rocks have been through a change. Their crystals are lined up and they are very, very hard. If you turn back just one page in your book, I really like the illustration that they have here. This rock is nice. It used to be granite like this. It was granite, and then you can see that as the plates pushed together, it really got squished and folded. We're talking about some extreme pressure that turned it into that beautiful rock right there. Nice. These are nice, but they're not as nice as that one. I wish I had that piece. Okay, so these metamorphic rocks, even though they are very, very hard, they can also get broken up into little pieces and they can turn back into sedimentary rock. We know that because we see an arrow going back up. If they get broken and crushed, they can turn into sediment, turn into sedimentary rock. Or these metamorphic rocks, they're deep down there, they could get melted, and then when they cool, they'll turn into an igneous rock. So when I was a little kid and I would pick up a fossil that I would find outside, we find a lot of these in Morrow County, I would think, wow, this has been here for millions of years, and I always thought that's the only kind of rock this has ever been. But this rock could have been on a journey. It could have been in a volcano. It could have been underneath of a mountain and moved around a lot. Now here's the really cool thing, is that we have tons of these sedimentary rocks in Morrow County and in Ohio, because these are actually the only kind of rock that are true to Ohio. All of our metamorphic rocks rode here from Canada on the glacier, and all of our igneous rocks rode here on the glacier. So I have another video and a book that will illustrate that a little bit better. But I want to talk about what you're going to do on your paper. We have the rock cycle set up the same way that it was in our book. We've got igneous down here in this corner. We've got sedimentary at the top, metamorphic at the bottom. I'm going to color code this a little bit. I'm going to make the word igneous red, and then I will make it red down here too. So what they're asking you to do is to read a little bit and to look at the diagram, and then if you need an igneous rock to turn into a metamorphic rock, what would you need? So from igneous to metamorphic, we need heat and pressure to turn an igneous rock into a metamorphic rock. So down here, I would write heat and pressure.